Hello everyone. Now we are going to talk about rectangular section. The objective of this lecture is to estimate the moment of inertia for the x-axis passing by CG using parallel axis theory, which means that we are going to take external x and y axes. We are going to estimate the Ix about these two axes. Then we are going to deduct the multiplication of the area by y bar squared in the case of Ix. Second step is to estimate the moment of inertia about the y-axis passing by the CG by using the parallel axis theory. Third step, once we have estimated the moment of inertia about x and moment of inertia about y, we can easily estimate the radius of gyration for Ix and Iy. Number 4, estimate the product moment of inertia for the rectangular section. Number 5 is to estimate the polar moment of inertia Jo, either at the CG or at the external parallel axis, as we are going to see. First step, we are going to get the moment of inertia Ix. We have two external axes, namely x and y. We are going to draw our rectangular section. The edge of the rectangular section, bottom left edge, coincides with the intersection of x and y. We have b as breadth and h as height. Then we have the CG, which we know that lies on the horizontal distance equal to b over 2, the vertical distance equal to h over 2, since the h is overall height of the rectangular section. In order to estimate the Ix, as we see before, we are going to draw a strip, will be rectangular strip. The width of that strip equal to the breadth of the rectangle, which is equal to b, while the height will be equal dy. And the y is the vertical distance from the CG of that strip to our external x-axis. This is the first step. Strip dA, which is horizontal strip for Ix estimation. X and y are two axes at the corner of the rectangle, while x dash, y dash are two axes at the CG. The x distance from the CG to this distance, as we said before, b over 2, while the yCG equal to h over 2, while the area equal to b multiplied by h. This is the area of the rectangle. If we are going to estimate the area of the small strip, which we call it dA, it will be equal to b multiplied by dy. We need the y distance from the CG to the x-axis. We are going to square it, as we are going to see in the next step. Ix we can express, this is the integration from 0 to h, we will start here and end there, of the multiplication of dA by y squared. Recall that dA equal to b dy, again multiplied by y squared. The integration performed from y equal to 0 to y equal to h. The integration, the b will come out. The integration of y squared dy from 0 to h will be equal to y cubed over 3, and the substitution from 0 to h equal to b, open brackets, we have h cubed over 3 minus 0 cubed, which is equal to 0. At the end, we are going to find out that the Ix will be equal to b multiplied by h cubed, all divided by 3. We know that this is Ix for the external x-axis, which is passing by the corner, while our aim is to estimate the Ix dash, which we are going to call it Ixg to denote that this is at the CG, so we call that Ixg. From the parallel theorem, we have the moment of inertia about the CG equal to the moment of inertia about any external axis minus the multiplication of the area of the section by the square of the vertical distance. In our case is h over 2 to be squared. Our Ix already estimated as bh cubed over 3 minus the area, which is bh, multiplied by h over 2 squared, bh cubed over 3, and this is minus bh cubed over 4. We are going to put denominator as 24. So 24 over 3 equal to 8. 24 over 4 equal to 6. So we have 8 minus 6 inside brackets, multiplied by bh cubed, all divided by 24. This is 2 over 24 equal to 12. So Ixg equal to the b multiplied by h cubed over 12. This is the famous equation of the moment of inertia for the rectangle, which is equal to the breadth multiplied by the perpendicular raised to the power of 3 divided by 12. Here, there is another way if we want to estimate directly without going to the external barrel theory. We are going to consider the x dash and y dash. And our strip, we will consider that the vertical distance is y from the x dash. Still, our strip width is b and the height is dy. And we are going to say that the Ix dash or Ix at g equal to the integration, but for this time our y will move from minus h over 2 to plus h over 2. The integration of dA multiplied by y squared, this is y squared, equal to the integration from minus h over 2 to plus h over 2 of b. The dA is b dy. This is a term for dA. And this y squared is the square of this vertical distance. Then Ixg equal to the y squared, the integration of y squared dy is equal to y cubed over 3, all multiplied by b. Then we are going to substitute, and we make integration from minus h over 2 to plus h over 2. We get b over 3 outside, and we open one bracket. Inside the bracket is h over 2 all cubed, which will give us h cubed over 8, minus, open again, minus the minus, we will substitute here as a minus h over 2, so it will become minus h cubed over 8, minus multiplied by minus becoming plus, so we have b over 3, and we get h cubed outside, so we have 1 over 8 plus 1 over 8, so this one will come at the end as bh cubed over 12, which is the same result obtained by using the external parallel theory. Thanks a lot, and we'll continue with the next topic. Goodbye.